Let's do a numeric problem on the Rain Man concept, and that way you will build the confidence in representing the problem as a vector diagram and then going on to solve it. We are given that the rain falls down vertically with a velocity of 4 meters per second. A man is moving towards the right with a speed of 3 meters per second. At what angle with the vertical does the rain strike the man? This is another way of asking at what angle with the vertical does the man have to tilt his umbrella? Let's draw the vector diagram first. The rain falls at a speed of 4 meters per second vertically downwards. So the red vector VR has a magnitude of 4 and the direction is vertically downwards. The man walks with a speed of 3 meters per second to the right. So the blue vector VM has a magnitude of 3 and the direction is towards the right. The vector VR is the vector sum of VR with respect to M and Vm. So we can also draw the vector VR with respect to M. And that would complete the vector triangle. The direction of VR with respect to M will be such that the addition of VR with respect to M and Vm in vector terms would give us the velocity of the rain with respect to the ground. And we have seen this derivation in the previous lesson. The vector VR with respect to M is the vector that tells us the speed and direction of the rain as it strikes the moving person. So in terms of vectors, if we are to find the velocity VR with respect to M, then it is the velocity VR minus the velocity Vm. In vector notation, the velocity of the rain with respect to the moving man is minus 3i minus 4j. So it will point into the third quadrant as shown by the green vector. In the vector diagram, the velocity of the rain is minus 4j and the velocity of the man is 3i. And in completing this vector triangle, the velocity of the rain with respect to the man would be this vector, since it has to satisfy VR with respect to M plus Vm equals VR. So the magnitudes and directions of VR and Vm are known here, and we need to find the magnitude and direction of VR with respect to M. Since the rain falls vertically and the man walks horizontally, this will form a right angle triangle and should be easy to solve. Now we have to find the angle theta. This is the angle made by the umbrella with the vertical. We know the magnitude of VR, which is 4, and the magnitude of Vm, which is 3. Since we have a right angle triangle, theta will be the tan inverse of 3 over 4, which is approximately 37 degrees. So the man would have to tilt his umbrella at 37 degrees with the vertical in order to protect himself from the rain. The magnitude of VR with respect to M is 5, as it is the hypotenuse of a right angle triangle. So the rain falls vertically downwards at 4 meters per second. but to a man who's walking at 3 meters per second, the rain appears to be approaching him, making an angle of 37 degrees with the vertical and hitting him with a velocity of 5 meters per second.